Welcome to Frank Buckley Interviews. This time on the program, look up into the night sky, because in amongst the stars is evidence that we're not alone. That's the provocative theory put forward by the longest-running chair of the astronomy department at Harvard University, Dr. Avi Loeb. And not just that. Professor Loeb says in late 2017, our solar system was visited by what could be something created by advanced alien technology from a distant star. Other scientists have suggested in papers published as recently as this week that the visitor was just something that looked like this, a space rock made primarily of ice. But Professor Loeb says the evidence suggests this was no simple rock and that its origins were artificial and alien. He writes about it in his book, Extraterrestrial, the first sign of intelligent life beyond Earth. And I am delighted to welcome Professor Loeb to the program. Sir, thanks very much for joining us.
Thanks for having me.
We will get to your response to the just published papers knocking down the alien aspect of the theory a little later in our program. But let's begin in October of 2017 so that we understand just why this object got so much attention in the scientific community. What happened? What was observed? How was it discovered? And what makes you think it was made possibly by alien technology?
This was the first object spotted near Earth that originated from outside the solar system. And we knew that because it was moving too fast to be bound to the sun. And so the first association of this object was with a comet that came from another star. The object was discovered by the Pan-STARRS telescope in Hawaii and was given the name Oumuamua, which means a scout in the Hawaiian language. And when astronomers tried to look for any cometary tail around it, they couldn't see any. And so it was clearly not a comet. The Spitzer Space Telescope looked very deeply for any gas around it, couldn't find any carbon-based molecules. So it was clearly not a comet of the type that we have seen before in the solar system. But people said, well, maybe it's an asteroid, just a bare rock that doesn't have any evaporation off its surface. The problem was that as more data came in, it became clear that the object has an extreme shape because the amount of sunlight that it reflected was changing by a factor of 10. And that implied that it's 10 times longer than it is wide projected on the sky as it was tumbling. And moreover, the best fit to the data was that of a flat object, a pancake shape, not cigar shape. Sort of like a piece of paper tumbling in the wind. And moreover, after that, the object showed a deviation from an orbit that is shaped just by the sun's gravity. And the question was, what is pushing it away from the sun in such a smooth way, a force that declines inversely with distance squared from the sun? And the only sense I could make of that fact is that it must be pushed by reflecting sunlight. It's sort of like a sail, a very thin object that is pushed away from the sun by the reflection of sunlight. We've seen such an object actually again in September 2020 with the same telescope. It was given the name 2020 SO, and then astronomers realized that it came from the Earth. It's actually a rocket booster that was launched into space in 1966 as part of a mission to the moon. And we know that this object is thin because we produced it. And indeed, it showed a deviation as a result of reflecting sunlight and didn't show any cometary tail. So it shared the qualities of Oumuamua. We know we produced it. The question is, who produced Oumuamua? Nature doesn't make sails.
Right. And so these things together made you come up with this theory. And were there other possible explanations? Obviously, other scientists have said, well, that's interesting, but we prefer to stick with what we know in the world of physical science, or something to that effect. As you were coming up with your theory, did you discard other ideas, and how did you go about doing that?
Well, so after my paper appeared in the subsequent couple of years, there were a number of suggestions. And as you mentioned before, even this week there were two papers published trying to explain it from a natural origin. And I should say that all of the suggestions on the table, there are four of them that associate Oumuamua with a natural origin. All four of them contemplate something that we have never seen before. So the latest one, just to give you an example, talks about a nitrogen iceberg. And we can talk about it later, why that is very unlikely. There was another one that said maybe it's a hydrogen iceberg. And then because hydrogen is transparent, when it evaporates, we can't see the cometary tail. And the problem with that is that hydrogen can be evaporated very quickly. And so such an iceberg will not survive the journey. There was another suggestion, maybe it's a cloud of dust particles, very loosely bound, sort of like a dust bunny that we find at home, except the size of a football field. And the problem with that is, as it gets close to the sun, it will be heated by hundreds of degrees, and it wouldn't maintain its integrity. The material strength is not high enough. There was another suggestion, maybe it's a fragment, a piece of another object that was broken when it passed close to a star. The problem with that is such events are very rare, but also usually you get a piece that is cigar-shaped rather than pancake-shaped, the way Oumuamua looked. And so all of these proposals have major flaws. And given the fact that all of them contemplate something that we have never seen before, it makes sense, in my opinion, to consider an artificial origin.
And just so we understand what that means, you're not saying that somehow this observation suggested that you saw a spaceship or aliens inside, or that you have some theory that goes beyond suggesting that this could be alien in origin. Tell us what you are saying and what you're not saying.
Right. So all I'm saying is it's something that we've never seen before. And an artificial origin looks more plausible than a natural origin, and that we need more evidence of objects that resemble this one. So when I go to the kitchen and I see an ant, I get alarmed because there must be many more ants out there. So there should be more objects of the same that we will find in the coming years. And then when we see one approaching us, we can send the spacecraft with a camera that will take a close-up photograph. And, they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book.
And you mentioned this idea of a light sail. Talk to us about what that would entail and what it would suggest about how it got here and who might put it here.
Right. So a light sail is just like the sail you find on a boat, except it's not being pushed by the wind. It's pushed by reflecting sunlight. And we're currently developing this technology for space exploration because it offers the advantage of not needing fuel to be carried by the spacecraft. So it's a very elegant way of propelling cargos. And, it could be that Oumuamua was not designed as a light sail, but it's just a piece of material that was ripped apart, a surface layer from a spacecraft or something else that is just very thin and it's pushed by sunlight, just like this rocket booster that we found from 1966. All it needs to be is thin so that it has a large area for its weight, and then it will be pushed by sunlight. Now, if we imagine it being a relic of another civilization, most likely it's very old, billions of years old, so it's not functional anymore. So, sort of like finding a plastic bottle on the beach among all the rocks. It's not that it can be punctured, it may not be functional, but it indicates, it gives us important information that a civilization is out there that made it. And the next ones that we find, we could, in principle, examine much more closely. It opens our eyes to the possibility of space archaeology, looking for relics of other civilizations, not necessarily trying to establish contact with them, because many of them might be dead by now. So instead of looking for radio signals, that require the counterpart to be alive, we can look for the relics they left behind. Just like in archaeological digs, many of the cultures on Earth do not exist anymore, but we find evidence for them.
And we should remind people, you're the longest running chair of the astronomy department at Harvard University. You're not someone who's just going to put a theory out there without giving it great thought and consideration. And when you did this, you must have known you were sort of going out on a limb in your community. I want to talk to you about that shortly. We're going to take a short break right now. And when we come back, do you remember this?
Look at that thing, dude. There's a whole fleet of them. Look on the ASA.
What did those U.S. Navy fighter pilots see? We're going to ask Harvard astrophysics professor Avi Loeb what he thinks about these encounters.
There's look at that thing. It's rotating.
U.S. Navy fighter pilots there locked onto what the Department of Defense has acknowledged as unidentified aerial phenomena that seem to defy the laws of physics. Welcome back to Frank Buckley Interviews. We're back with Harvard astrophysicist and the author of the new book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, Dr. Avi Loeb. Professor, I wanted to show that video because when I mentioned that I'd be speaking to you about the 2017 discovery and what you focus on in your book, a friend of mine asked me about the encounters that we just talked about, filmed by the naval aviators. Professor, what are your thoughts, before we move on, about those events that happened off the East Coast and the West Coast, happened in the early 2000s?
Well, I think they're interesting, and the reason they were of interest to the government is because they may indicate technologies of other nations that we want to know about. That's why some of the Pentagon reports were classified. But my view on this is that the instruments used to detect these unusual phenomena were not optimized for that purpose. And as a result, we don't have credible scientific evidence. I think that instead of obsessing with old reports that were based on old equipment that we used to have, we should deploy the best cameras, the best audio sensors in the same locations and look for unusual events. And we can consider it as a scientific experiment. In science, reproducibility is extremely important. The fact that someone reports something and it can be reproduced by others makes it much more believable. There is this biblical story about Abraham that heard the voice of God that told him to sacrifice his only son, Isaac. But if Abraham had a cell phone with a voice memo app, he could have pressed the button and we would all be convinced that it really happened. He didn't have that, and then we have to decide whether to believe that story.
Right.
So my point is, scientific instruments nowadays provide an objective way of assessing whether such reports make sense. And that's the way we should proceed forward. And it wouldn't cost a lot of money to actually try and replicate those results.
And yet the reaction to these unidentified aerial phenomena is sort of emblematic in the scientific community of how scientists, astronomers, astrophysicists often react to this kind of information. Even us in the news business, we always sort of tell a story like that with a wink and a smile, as if, of course, it's not truly alien technology. You're saying no. At least in the case of what we observed in 2017, we should be thinking about the possibility of alien technology. Why is it that the scientific community finds it so difficult to embrace that in a genuine way?
Because it takes it out of its comfort zone. There was a colloquium about Oumuamua at Harvard, and when I left the room after it was over with a colleague of mine that worked on rocks in the solar system for decades, that colleague said, Oumuamua is so weird, I wish it never existed. And I was appalled by that, because in science, when you are presented with evidence that doesn't quite conform with what you expected, that's an opportunity to learn something new. Nobody expected a century ago that we would come up with quantum mechanics, which is currently the foundation for all the devices that we use. And that was a complete surprise, and Albert Einstein resisted the inference from quantum mechanics that there is spooky action at a distance. He was wrong. It took him out of his comfort zone. It still takes us out of our comfort zone, but that's not an indication that quantum mechanics is wrong. We just need to learn from the evidence and revise our notions, and we should be open-minded. So it's not a matter of how many likes an idea has on Twitter. The question is, what does the evidence tell us? And if the evidence looks credible and scientific, as in the case of Oumuamua, we should contemplate a revision to our prejudice, and if you go back to ancient history, humans used to argue that the body has a soul and therefore anatomy should be forbidden. That was a controversial subject. And imagine if scientists would say, we don't want to discuss this controversial subject. We don't want to do any operations on the human body. Where would modern medicine be? My point is simple, that science must address subjects of great interest to the society, to the public, using the scientific method by collecting evidence and being guided by evidence rather than prejudice.
And people like you who are in academia, who want to raise these sorts of questions, when you do, are you ridiculed? Do you have difficulty finding funding to take on these kinds of challenges?
Definitely. In fact, I often get comments that are not constructive, that are personal, whereas I just follow what basketball coaches advise their team members. Keep your eyes on the ball, not on the audience. So I don't have any footprint on social media. I don't care how many likes I have on Twitter. I'm just guided by the evidence, because that will stay. And people's opinions would move around. And in my view, the best way to move forward is to collect more evidence. The one reason we might not figure out that we were wrong in the past is by ignoring any evidence, saying it's always rocks, it's never aliens. But that would be just like a caveman presented with a cell phone. A caveman that is used to playing with rocks would argue, oh, the cell phone is just a shiny rock.
Just so I'm clear, you've certainly raised this as a theory that Oumuamua may have been created by alien technology. Are you convinced that it is, in fact, created by alien technology, or are you asking us to just consider that idea?
Well, in science, we are never absolutely sure of an interpretation. We just put all the possible interpretations on the table, look at the evidence, and ask at any given time, what's the most likely interpretation? And at the moment, I should say that all the natural origin interpretations look less likely to me compared to the artificial origin. Take, for example, the most recent suggestion that it's made of nitrogen, pure nitrogen. And the problem with that is nitrogen is produced together with carbon in the interiors of stars. You never get just pure nitrogen. You get a mix of nitrogen and carbon in almost every object that we see. And carbon could not have existed, could not have evaporated from Oumuamua based on the observations by the Spitzer Space Telescope. There are very tight limits on all carbon-based molecules. And you couldn't have evaporation of nitrogen without carbon.
Right.
The other thing is, we've never seen a nitrogen iceberg. And, we've looked at numerous, there are about, a billion objects bigger than the size of Manhattan Island in the so-called Oort cloud of the solar system. And all the objects we have seen from there appear to be rocks, the kind of objects that we expect, that are the building blocks of the planets that we see.
Right.
None of them was pure nitrogen.
Yeah.
So to argue that the first object, which should be, by the way, the most common, was made of nitrogen, to me is very strange, because it's a rare, a rare oddity. You know, it's just something that we've never seen before. And why would the first object look like nothing we've seen before in the solar system if all stars resemble the solar system? And there were other issues. You know, there are many anomalies of Oumuamua that are not explained by this model. So altogether, I would say that the suggestions made for natural origin, first of all, advocate for something we've never seen before. And second, if you look at the details, they have major flaws.
Right. Professor, we're going to have to take one more quick break, and when we come back, I'm going to ask you the question, will we find that there is some sort of alien technology somewhere beyond our solar system during our lifetime? So we'll be right back. And welcome back. We're with Professor Avi Loeb of Harvard University, a renowned astrophysicist. Professor, here's the question that I want to ask you. Will we learn that there is alien technology or alien life outside of our solar system in our lifetimes?
It really depends on us. If we assume that there is nothing out there and not even check, then we will find nothing. If you're not ready to find wonderful things, you will never discover them. But if we use our telescopes for research and we fund such an effort at $1 billion as we do other efforts in astronomy these days, then I'm very confident we will find evidence in our lifetime.
Professor Loeb, thank you very much. Once again, the book is called Extraterrestrial. We'll have more on the audio podcast. We hope you'll tune in for that. Thanks for joining us. We'll see you next time.